This is Miss Martin speaking to her students in her pre-algebra classes. Today we're going to talk about volume of spheres. A sphere is like a ball, just a three-dimensional ball. You can see how it's drawn as a circle with a little oval in there. That's supposed to represent like a flat circle, like if you sliced the sphere in half, or an orange, you would have that circle for the half that you cut, right? Well, there's a radius. We can find a radius in that sphere. And here's the thing, the cool thing about this formula, that number right there, all you need is a number for the radius, and the rest of it is already built into the formula. The formula is 4/3 times pi times the radius cubed. Notice I said cubed, I did not say squared this time, like with cylinder and cone and circle. For the sphere, the formula is again 4/3 times pi times r cubed. Okay? Now, when you write it out, it looks like this. 4/3 times 3.14 times the radius times itself 3 times. Or you can do like what I like to do when I'm working with cones, because cones also starts with a fraction. If you remember in the formula for cones, 1/3 times pi times r squared times h, right? This is 4/3 this time. And here's how I like to do it. I like to say 4 times 3.14 times the radius cubed, all divided by 3, because there's that fraction, and here we are, there's that fraction there. I'm just multiplying everything in the numerator. All of this is in the numerator, and then that's in the denominator. Okay, now there's a hint, and when I have told students in the past, especially like algebra kids that I had, they were real quick to catch on that, hey, every single time you use the sphere formula, you're going to say 4 times 3.14. That's what you're going to always be doing, unless we're doing in terms of pi, and that's a little different because remember, instead of 3.14, we keep the pi symbol. But for all intents and purposes, we always have 4 times 3.14. Well, hey, why don't we just multiply that out right now and get an answer of 12.56. From that point forward, why can't we just put that in, plug it in for 4 times 3.14 and just say 12.56 times the radius cubed, all divided by 3. To me, that makes it so much easier, and the brain doesn't hurt so much. So, well, at least I'm hoping it doesn't. All right, so here we go. Here's the lesson that we set up. 10 problems, 5 just using the formula, and then 5 word problems using the formula. Okay, so again, when you're working with a sphere, I like the way Alex has this out to the side. They are using a radius, and then they're using a D for diameter. So they're kind of giving you a hint, like you better make sure you read very carefully what they're giving you. Are they giving you the radius or the diameter? If you look again, there's no diameter that's used. It's the radius. So if you get a diameter, what do you have to do? That's right, cut it in half. Okay, so here we have a radius of 7.7, and it says calculate the sphere's volume. All right, and it's noted, they also tell you to use the value 3.14 for pi. Okay, so we are going to be multiplying with 3.14, and round your answer to the nearest tenth. And it says do not round any intermediate computations. That really sounds mathy, doesn't it? And you know what they're really just saying? Just write down every number that you get out of your calculator. Don't round anything until the very end. Everything that you're using to multiply your radius cubed times the rest of the formula, 3.14 times 4 or 12.56 divided by 3, all that, do not round at that point. Only round your answer. The last number after all the calculating, get it rounded to the nearest tenth. All right, so here we go. We're going to use the formula. I'm going to go ahead and I'm going to say that I'll write it out the old-fashioned way for a second. Well, not my old-fashioned way, which is 4 times 3.14 times 7.7 cubed, and I'm going to divide all that by 3. Okay, so I will tell you, I do know that 4 times 3.14 equals 12.56, so all of that is 12.56. So I'm going to start out with 12.56, okay? Actually, I'm going to start out with the 7.7 cubed because I don't have any way to do exponents on my calculator. It's just a plain old calculator like probably most of you have. 7.7 times 7.7 times 7.7 equals, I just like to see that first, all right? Now, see all those numbers? I'm not touching them. I'm leaving them there. Now I'm going to times that by 12.56, which is 4 times 3.14. So times 12.56 equals, look at that huge long number. I know, you're saying, what? I have to write all that? No, not yet. Divided by 3. That, don't forget to divide by 3. Okay, now this has a very long number of 1911.3514. I might as well go ahead and write that down. This all equals 1911.3514, okay? And it does say to round this answer. This is the answer. This is where we're going to round to the nearest tenth. If you remember your rounding rules, whatever you're rounding to, meaning we're going to end with just one number to the right. We got to get rid of all those numbers. But first, that 5 is going to boss that 3. That 5 is either going to tell that 3 to stay the same or go up 1. Rounding rules are, if the boss, the number that's after, that's bossing this number, is between 0 and 4, then the number you're rounding to, the 10th, that number, stays the same. If this number is 5 to 9, and yeah, it's a 5, this number that you're rounding to goes up 1. Okay, so my answer is 1911. Don't touch any of that, but I am going to round this 3. It's going to become a 4. And again, we have to use our correct units of measure. We're talking centimeters. And remember, when we're doing volume of anything, does everybody remember what exponent we use? A 2 or a 3? If you said 3, you're correct. If you said 2, you're thinking area. 3 is volume. Okay, so there's the answer for number 1. And that's my number 1. Your number 1 is different, but it's just different numbers, but you're still going to use exactly what I did. I haven't said this before, but don't forget that you can always stop the video, go, rewind it a little bit, whatever you need, freeze it, pause it while you're working on your problem when you see mine done. There's so many ways that this can be helpful for you, this video, okay? All right, I'm going to number 2. I am going to go a little faster because once again, I don't want you guys having to get too bored with everything I'm doing. Diameter, that means I need a radius, not a diameter. And that means I have to cut 6.4 in half. Well, let's think about it. I'm going to cover up for a second. And what's half of 6? 3. And then cover up that. What's half of 4? 2. There you go. There's half of 6.4. So clever. And then calculate the sphere's volume. Okay, so I'm going to go ahead and I'm going to say 12.56. Why? Because 4 times 3.14 is 12.56. That's the last time I'm going to say it. From now on, if you skip and you get to this part and go, how should you get that? You'll have to go back to the beginning to know what it was that I said from the beginning. Okay, stop tuning out. Keep your focus. I feel like we're in a classroom. Yikes. All right, so 4.3.14, which is 12.56, times 3.2 cubed, all divided by 3, okay? I'm not going to go through this again, okay? I'm going to go ahead and tell you that when you multiply all of that together and then you divide by 3 and do not round any intermediate computations, so when you're doing all this work, you leave it as you're calculating. Then when you get your answer and you get something like this with a super long answer, you're going to, it says round to the nearest tenth again. This is going to be rounded to the nearest tenth. When you do that, you will get 137.2 And our units of measure was millimeters, and of course we're doing volume, so that's a 3. Okay, now I could have sat there and typed all this in, but I think some of you just practice typing this on your own. And then if you get this answer, then you did this right. If you don't get this answer, then you didn't do something right here. It was user error with the calculator, okay? All right, number 3. Radius, great, of a sphere is 6.5, so I don't have to cut it in half. It's already the radius, which is what I need for the formula. And what are the numbers? 12.56 times 6.5 to the 3rd power, all divided by 3. So what I like to do, you could go 12.56 times 6.5 times 6.5 times 6.5. I don't know. You can do it either way you want. You can multiply in any order, all right? I like to do my exponent first just because I guess I just want to follow that order of operations. That PEMDAS tells me do my exponents first and then multiply. So, and then divide last. Okay, so on this, if you have done all the math, number 3 is the volume equals 1149.8 when rounded, and it's meters to the nearest tenth, that is, meters cubed. So you can always pause and try all this on your own and then see if you get the right answer. When you're practicing this, this is what's setting you up to be successful with your own assignment, okay? That's why I'm going through this and giving you all the answers. Not that this will do you any good other than a teaching tool and practice for when you have to do it in ALEKS, okay? All right, number 4 on mine. This time it says a diameter is 11.6. All right, so yeah, on this one, you might as well just go ahead and use, I mean, I have my little tricks and my little ways of doing this. But you might as well, I could also just do it this way because a lot of kids just like to do this. They'll just cut 11.6 in half by dividing by 2, and you get 5.8, all right? So the radius, not the diameter, I don't need that, but the radius is 5.8, and now I'm gonna plug it into my formula, 12.56 times 5.8 cubed, all divided by 3, and when you do that, you will do not round any intermediate computations. At this point, you should realize that every single one of these, leave all the numbers intact. Don't round anything before the very last thing when you divide by 3. Then, after you divide everything by 3, then you can round it to the nearest tenth. And if you did it correctly, you'll end up with the volume equaling 816.9 centimeters cubed. Number 5. Oh boy, they love giving us these diameters. The diameter of the sphere is 18.2. All right, so when I have even numbers, that was my little trick before. I didn't have an even number here, even though I could have done something, but I won't even go into that. Okay, fine. A half of 11 is 5.5. 5.5 plus half of 6 is 0.3. Gee, I get 5.8. Bam. Okay, but that's just, some of you just went glazed over and said, Miss Martin, stop. Okay, but 18.2 I can do. What's half of 18? 9. What's half of 2? 1. There we go. There's our radius. I'm ready to calculate 12.56 times 9.1 cubed, all divided by 3. Yep, you keep saying, hey, isn't that what we do? We did that last time, the time before, just multiplied, we cubed the radius, and then we multiply times 12.56 and we divide by 3, and really that's what we do? Yeah, you do it for all of them. It's the same formula every single time. Round your answer to the nearest tenth, blah, blah, blah. Don't round anything in between. And when you do that, your answer, your volume will be 3155. And now Alex put 0.0 with centimeters cubed. I can only assume that this was a 0 and this was a number that was between 5 and 9 that wait a second. So if this is 0, oh, no, oh boy, sorry. This must have been like a 0, 2, something between 0 and 4, not 5 and 9. I would have rounded up. If this is between, the next number is between 0 and 4, this stays the same. And for some reason, we were going to call that a significant digit. So they wanted to keep that. I would assume that if you put this into Alex, and the fact that it is rounding to the nearest tenth, sorry, this is a stream of consciousness going here. Since I do want it rounded to the nearest tenth, and we did have other numbers to the right, if I did this, there would have been other numbers, and this would have stayed the same. You keep it as a tenth, okay? Hope I didn't just mess everybody up. Oh well. Okay, number 6. This is a word problem. So, let me move over here. Okay, same thing. All we're looking for is we just need a radius to find the volume, and darn if they didn't give us a diameter, and we need a radius. So if you cut 6 in half, the radius is 3. Okay, now I'm going to plug that into the formula using 12.56 times 3 cubed, all divided by 3. I'm going to show you something. I am going to do this one time to show you that when you do 3 cubed, you're going to see that that is 27, all divided by 3. And if you notice right there, I can cancel some stuff out. I can simplify. Keep saying cancel, and I mean simplify. I can simplify some stuff here because look at this. That's 27 and 3. That's 9. 27 divided by 3 equals 9. So technically, I can just go 12.56 times 9, and I don't have to divide by 3 anymore because this 3 just got simplified. With 27 divided by 3 is 9. You can do that. And sometimes math can make you happy. And when you do that, it equals 113.04. Okay, I know this is way over on the side. Darn it. Once again. Okay. All right, so I think you can see that. So what we found was the volume. What did we find the volume of? Because I never really talked about it to begin with. Okay, so they're making some solid metal balls for industrial uses. Okay, cool. The customer wants aluminum balls that have a diameter of 6 inches, and Heather must make 70 of these balls, okay, because her company makes these solid metal balls. How much aluminum will she need? Well, we just found out the volume for one of these balls, which is 113.04 inches, cubic inches. That's how much one is, but we need 70. All right, so here's the big question. Are we going to multiply 70 times 113.04, or are we going to divide 113.04 by 70? I'm hoping that you know if this is 1 and that's 70, well, that's not 70, so we're going to have to make it 70, so we're going to multiply by 70. When you do, the answer would be, and it says, and do not round your answer. Notice this. It says use 3.14 and do not round your answer. So whatever we get here is going to be, if tenths, hundredths, whatever, we keep it in our answer. And for that one, the answer is 7912.8, and we were using inches, and so our correct unit of measure is cubic inches, and so this means that for 70 balls, they're going to need this much aluminum, 7,912.8 cubic inches. I don't even know what that looks like. I mean, I don't know about you, but I'm not sure what almost 8,000 cubic inches looks like. But hey, Heather's company does. That's all good, well and good. So that's the answer. And so if you calculate all this, and if you can see how I did it, it'll help you when they have questions similar to this. Okay, I'm going to tell you something that I noticed. A lot of these word problems were using the same radius. They might have given you a diameter of 6 a lot, which means you got to have a radius of 3, and then when you're cubing that, it gets 27. Of course, when you divide it, all gets 9. So you're going to see a little bit of repetition in your word problems with some of the same numbers, and we're just thankful. We'll just take it anytime we can get it. Okay, the next question. I'm looking for volume. I need a radius. There's the radius. So I'm going to go 12.56 times 4.5 cubed. And people are saying, what? I have to go 4.5 times 4.5 times 4.5? Yeah, who cares? Decimals are the same. You can square and cube and do whatever exponent to any decimal you want. You just have a calculator. Stop complaining, for heaven's sakes. Okay, divided by 3. Let's see, on this one, yeah, I didn't calculate what that would be, but I did say how much all of this is, that equals 1 of whatever volume we're finding. We're just finding the volume of 1, whatever it was, and I'll get to that in a second. But this sphere's volume is, we know it's all about a ball. Everything's balls, right? All spheres, okay? So equals 381.51, which is for 1 of what? Well, let's find out. A manufacturer makes decorative globes. Oh, I love those kind of globes. I gave one of those to Mrs. McKeever, our assistant principal, for Christmas, one of those Christmas globes, out of silver in the shape of a solid sphere. So suppose each sphere has a radius of 4.5 centimeters. If silver is priced at $4 per cubic centimeter, how much will the silver cost? Oh, so we're talking how much money is it going to cost to make 1 solid sphere? Well, okay, this is not for 1 whole sphere. This is for 1 cubic inch. So now we have to, am I right? Suppose each sphere has a radius, and the silver is, oh no, it's for a sphere. That's for the sphere, duh. Times this, or divide this by 4. What do you think? I'm hoping that you said times, because you're right. Multiply it by 4. Okay, $4 for each one of these. This is for the silver. Okay, so not rounding anything, we get an answer of $1,526.04. That's how much, wow, each sphere is priced at $4. So each of the cubic inches, yeah, it's each of the cubic inches inside. I was right the first time, sorry. And it's $4 for each cubic inch. It's $1,526.04. I did not spend that much on my decorative globe, I'm just saying, but that's how much this one is. Oof, cha-ching. Okay, number 8. Boris Company makes solid balls out of scrap metal for various industrial uses. Okay. His current task is to make a batch of aluminum balls with a radius of 4.5. I'm hoping somebody with a memory remembers that we saw a radius of 4.5 in our very last question. Yay! If he has a total of 76,302 cubic inches of aluminum, how many balls can he make? Well, and it says use 0.3.14 for pi and do not round your answer. I accidentally was playing around with this. And I thought I was writing on my answer sheet, but instead I wrote this out. So it's already pre-done for you. 4.5 cubed was used in the very last question as a 4.5, I'm sorry. 4.5 as a radius was used in our very last question. So we're using the same radius. So I did not just isolate and multiply my 4.5 times itself 3 times and keep that answer in the last question, but I did for this. So keep all your answers. Go ahead and cube all your radiuses and keep your answer, because you may be able to use it again. And you actually do for the next 2. We're using one that was previously used. So always keep your radius cubed answers. So you can just plug that in like here, okay? So 12.56 times 4.53 cubed divided by 3 equals 381.51. Now, see that huge thousands and thousands of numbers? That's not going to be a multiplication question. I'll just give you that right now. When it's that big, we're going to end up dividing. And that's how much aluminum he has. And they want to know how many of the spheres can he make out of that much aluminum. So out of that, we're dividing what it is for 1 sphere, dividing. And as an answer, we get 200. That's what I love. And it's 200 of the spheres. Okay? Now, or the balls, whatever they want to call it. Okay, so here's the crazy thing. That's such a big number, and these are all big numbers that we keep using, but look what it comes down to, 200. That's what I love about math. It's so interesting and weird. Okay, a company makes chocolate candies in the shape of a solid sphere. Okay, each piece of candy has a diameter of 6. Well, we have to cut it in half. What's half of 6? We need a radius. The radius is 3. If a box of candy contains 15 pieces of candy, how much chocolate does the box contain? All right, use 3.14 and do not round your answer. So 12.56, which is the original, remember the original formula is 4/3 times pi times r cubed. And 4 times 3.14 in my numerator would be 12.56. So there's my 3.14 times 4. Okay, times the radius, which is 3 cubed, all divided by 3. Doesn't this ring a bell? Didn't we have a 27 in the numerator before? Yes. And I did all this. I said, hey, 27 divided by 3 equals 9. Yes. So 12.56 times 9. And what did I, oh no. Oh, there it is. Equals 113.04. We used this back at question 6. When I was doing number 6, we used this very same number. And now it says each piece of candy has that much chocolate. That's for one chocolate. And there's 15 pieces of candy. Now, see, here's the other thing. When you have huge, huge, huge numbers, you know to divide. When you have small, small, small numbers, usually 1 or 2 digit numbers, you're going to multiply. So I multiply 113.04 times 15, and I get, where am I? Question 9. Is that right? 9, yeah. Is 1695.6, and it's centimeters cubed. And what are we saying that is? That is the amount of chocolate in the box that has 15 pieces of candy. And don't round anything. Do not round. That's why it has a 10th as an answer. Okay? So if you do all the math and you get the same thing as me, you did good. All right, the last question on a very long video. Sorry. Spheres, though, scare people. I've already had a text from, or a remind text from one of the kids, and I said, just wait, I'm making this video today. So here we go. Frank's company makes solid balls out of scrap metal for various, same verbiage in all the same questions. Frank's company was Heather's company a minute ago. And then there's Boris. Where did they get these names anyway? I wonder if they're family members. I don't know. For one project, he must make steel balls that have a radius of 3 inches. If the steel costs 25 cents per cubic inch, how much will the steel cost to make one ball? Okay, so 3.14 for pi, do not round your answers. So 12.56 times 3 cubed divided by 3. Well, looky there. This is why I paused a minute ago, because 9 and 10 had the exact same, look, 9 had the exact same numbers, right? I'm gonna stop there. I'm not gonna do anything else because I already know that's gonna be my answer. That equals 113.04. Thank you, Alex, for making it easy. Now, so if this is how much steel is in one ball, and it's 0.25 cents, or that was funny, 25 cents per cubic inch, and that's how many cubic inches there are in one ball. I'm not going to divide. What am I going to do? I'm going to multiply. Oops, 0.25 times all of that, and I'm going to get $28.26. That's what I'm going to get, and that's how much it costs, how much the steel will cost to make one ball. All right, that's it. Just shy of 30 minutes on this one assignment. I promise you I'm going to get faster at this. I'm just a little slower today. This is spheres. Once again, I'm going to take this off. And this was what I would hope that you would write down in your notes if you haven't done it already. But this is volume of spheres. Signing out. Thanks. Bye.